Okay.
NH3 solid.
NH3 solid.
Melts at negative 78 degrees Celsius.
Negative 78 degrees Celsius.
And then gives the equation NH3 solid plus 5.66 kilojoules.
Plus 5.66 kilojoules.
And then you have the rest up there. What amount of heat is given off when 6.46 grams of NH3 liquid
Solidifies. Okay. First thing you need to do from this equation is figure out your molar enthalpy of melting. So delta H melt for ammonia is what? Saeed?
5.66 kilojoules.
No. It's not per mole. You do. Okay, so this is the molar enthalpy of melting. It's positive because it was a reactant, so you have to put energy in to melt it. You wanted a question where we're going in the opposite direction. We're going from a liquid to a solid. So the energy change is the same.
Is it just negative?
It will be negative 5.66 kilojoules per mole. So when they ask you how much heat is given off or how much heat is required, they're always talking about using the quantity you're given and the molar enthalpy. You have to have a molar enthalpy. So now we know that value. So you're going to stick it into this equation.
Would you be fine if we just did dimensional analysis?
I would be fine if you did dimensional analysis. You need to find the moles of ammonia. So divide it by the molar mass. You've got the moles. Multiply it by negative 5.66. Okay?
I'm good.
Okay, good. You're so, what is this value? This will give you the rate of change, how silver nitrate changes over a 25-minute period as a rate, moles per liter per second. Give me the rate of production of the formation of silver.
Would it be the same?
How would you show that? How would you write out the formation, the rate of change of the increase of silver?
It would be times molar,
Yep.
times the, what's it called?
Mole
The
ratio.
mole ratio, which is 2/2, which is just 1.
Yeah. But now you just change the unit. So now the rate of change, concentration of silver, well, actually it would be mass of silver, with a change in time is 1 times 10 to the negative 5 mole per liter per second. But this time it's a plus, right? And we do this. We do this a lot. If you have to use silver nitrate, you will do this because it's very expensive. It contains silver. I think 20 years ago, it was like about $500 for like 100 grams or something crazy like that. Yeah. Like it's very expensive because it contains silver. So you recover silver nitrate by precipitating out silver. So you've got 2 H2s plus 2 NOs goes to 2 H2O and N2.
So what's the catalyst of this reaction?
Bless you.
Correct, just saying there's no catalyst because none of them stay the same.
There is nothing that is used if you have a catalyst, it's going to, bless you, it's going to appear on the left-hand side first and get returned on the right later. These reaction intermediates are a product, then a reactant. A catalyst is a reactant and then a product. It will not show up in the overall equation. So technically,
So like it'll cancel out.
it will still cancel out, but it will be a reactant before a product.
Is that like if the NO2 at the
Oh.
top was a catalyst, and then the NO2 at the second one was on the opposite side? That mean there was catalyst?
So if this was over here and this was over there, that would be a catalyst.
Okay, so it's an intermediate if it's a product first.
Product and then used up in a subsequent step.
And then a catalyst is a reactant and then a product, but it still cancels.
It will still cancel. I think you actually have a question. So the rate will be equal to some constant K times the concentration of NO times the concentration of H2, and they are to some exponent X and Y. So if we double the concentration of NO, the rate is doubled. So what is X? 1. So what is the order with respect to NO?
First.
You have to say with respect to NO, it's first order, or it's first order with respect to. Okay? And now NO's done, so let's do H2. What is Y? 2. So what is the order with respect to? It's second order with respect to H2. So this becomes our rate law expression, or our rate law equation. So if this is our rate law expression, does this reaction occur in one step? What do you think, Saeed? You got a 50% chance of getting it right.
I'm assuming that has to tie in with the exponents, so overall to third thing.
A third thing. That won't get you any marks on your assignment.
Third order.
It is third order overall.
So
And this is your balanced chemical equation. So, is this a one-step reaction? Tamara, you're shaking your head. So you are saying no. And you are correct. Do you know why? No.
I have a question.
Okay.
In the equation, is like not the balanced chemical one, just like the R equals K. Is it supposed to be NO2 in the brackets or just NO?
I don't know. NO. There's so many 2's up there. Thank you. NO. Okay. So, if this is the rate law for this reaction, what does that tell you? What do you get from the rate law expression? The blank in the blank blank. The blank in the step. The blank in the blank step. One of those words begins with a C, the other one begins with an S.
Concentration of the slowest step.
Not the concentrations in the slow step. You got the slow step part right.
Speed of the
No,
reaction?
no. It's the C. What's the C?
Constant.
No. We're talking reaction mechanisms here, right? Does this match up with this? No. The coefficients from this reaction would have to be the exponents in your rate law equation if this reaction occurred in one step. Because the rate law expression comes from your slow step. So you would have to have H2 and NO, right? Are you getting me? You have to compare your rate law expression to your reaction. The coefficients have to be the same if it's a one-step reaction. If not, it's going to occur in more than one step. So there will be a reaction mechanism.
Will it be said that, like, this rule can only be used for elementary processes, right?
Well, you get experimental data to get you the rate law expression. This will happen for an elementary step, right? This occurs from one step in the reaction. Your rate law expression comes from one step. So it's either the overall or it's your slow step. But if they're the same, then you know that it happened in one step. If your overall is the same coefficients as your rate law expression, happened in one step. Otherwise, it happened in more. A lot of times, if you've got 2 molecules of this and 3 molecules of that, or 2 molecules, 1 molecule, it's going to occur in more than one step because you've got so many molecules that have to be aligned in the correct orientation and have a certain amount of energy or speed with which they react and collide.
So, can you know how many steps?
You can kind of make it up. For this then would be R is equal to K. That's your rate law expression. It's 0 order with respect to B. So you could either put B in and put it to the 0 or not put it in at all.
Can you explain this up again? The 2x equals 2x.
We double the concentration. We doubled the rate. So your exponent goes with your concentration. So 2 to some exponent gives you 2. So that exponent has to be 1.
And then what happened at the bottom?
We doubled the rate. The concentration didn't change. So you have 0.2 divided by 0.1, 2. 3 divided by 3, 1. So that's how you get the 1 on that side. So here, 2 to the y equals 1, y equals 0. So it says, state the rate law equation. It wants to know the rate determining step, and it wants a possible mechanism.
Is that the rate determining step?
That's the rate determining step. So what would you say? If your reactant is A2, what's the only thing that A2 can do? It's got to do something. This is our overall. We want to get A2 plus 2Bs goes to 2ABs. It's right up here. So this is our rate determining step, right? You get your rate law expression. So what is the only thing that could happen to A2? It's got to do something. Can you put a 2 in front of that and have 2 A2s? No, because the coefficient has to be 1. So what is the only thing A2 can do? Split up. So now we've got 2 A's. Is there any single A's in our overall reaction? No. So we have to use it up. Right? So you could either do this twice or if you add these two up, what would you get? Your reaction intermediates cancel. You end up with A2 plus 2B's makes 2AB's. Oops. Which is your overall equation. And they'll do this in the textbooks. They'll give you A's and B's and tell you to come up with a reaction mechanism.
So that's the reaction mechanism?
Yeah, I could have thrown in a D if I really wanted to. Just got to make sure it gets used up. Because there's no D in your overall. Could have thrown in a catalyst.
So when it asks for the rate determining step?
The rate
that's-
determining
it's just
step
R equals K.
has to do with whatever's there.
So when you do the coefficients from the 2A and like the 2B, like, couldn't you just leave it like A?
The A plus the B, yeah. But I need 2.
Like
I need 2 of these in my overall
just so you can like, you only did it just so you can like balance it?
Yep.
Okay.
to get your overall.
Yeah.
So if I give you a reaction, could you give me a reaction mechanism? You want just 2 steps? Or can I give you a 3-stepper?
Sure.
Okay.
5-step final line. See, you can barely do one.
Very funny. Yeah, step.
R is equal to K. Y squared Z. Your overall is X plus 2Y plus 2Z goes to X, Y, 2, Z2. We know this is not going to happen in one step because there's 5 molecules that have to align in the correct orientation with the correct speed in order to join to make one massive compound. So, what do you know right off the bat based on this information? What information can you start with?
Why is there no X in the top?
Because X is not in the slow step.
Is that a Z? I think
That's a Z.
So does X have a exponent of 0 then?
No, it's just not in the slow step reactants. You know this is going to happen in more than one step. How do you know that? This exponent is 2, but Z is not 2. And there's no X. So the combination of the 2 missing from the Z and the no X tells you this is not one step. So what does the slow step give you? The reactants from the blank step. What blank? Slow step. What are the exponents in the rate law equation? 2 and 1, so those are your coefficients. I just almost pulled them out. Okay, so I almost went to the board to write it. Okay, so slow step, we need 2y plus a z to make some product. What do we want to make the product? How about we make it zy2? Yeah, because the products don't count, right? We don't care what the product is because it's going to be a reaction intermediate. What's going to happen is that reaction intermediate is going to have to come up on the reactant side somewhere. So what else do we need from here? We've got 2 y's, that's taken care of. We need another z, we need another x. So what happens if we say zy2 oops. Could you have your zy2 plus something? Sure, let's make it plus an x. And then we make an x, y, 2, z. Are we finished? No? So what else do we need? We need another z. So is x, y, 2, z coming up? Is it in our overall? This is right here? So we're going to use that as another reactant, y to x, z, plus, you said we need another z? Now x, y, 2, z2. So, this got used up. This got used up. So overall, we've got 2y, 2z, plus an x, x, y, 2, z2. Is that our overall? Yeah.
So you're going to make a question like this?
Could totally.
Can you move it up a little bit?
Sorry, yeah.
I just don't like with like any question to me, I don't understand like what the point of doing all that, those steps are. Like I don't know where you get those from. Like,
We made these up.
Yeah, but like, that's what I'm thinking too, like, where do you like get the,
like how you know.
Start with a slow step.
start with the R equals?
Start with, you know,
It
your
will-
slow step.
It will give you.
It will give you, you'll either have to figure it out or they'll give it to you. So then that goes on the left-hand side. A reaction intermediate, you could have put C if you wanted. And then put C over here plus X. They will cancel. So it doesn't matter what you make them. Right? As long as you have a plus and X, you could have makes a D. You're trying to make something that will cancel so you can introduce your next reactant so that you can have it in your overall.
That's just, we would just do that if you ask for a protection mechanism.
Yeah, it doesn't matter what your products are because your products are never in You react in your overall. So here you go. This is what the book said.
Also, models in scenes 7 and 9 are reminded of our rehearsal in the dance room Thursday at lunch. All students interested in helping out backstage with hair and makeup are asked to come in a short meeting on Friday at lunch in the fashion room. Remember, if you are in need of community service hours, they are available. Scenes 3 and 6 will rehearse on Monday at lunch. It's crunch time. See Miss Barrett if you have any questions. Girls soccer. Tryouts will be held today after school. A12 planning meeting. A12 planning meeting.
This is the reaction mechanism that the
Please bring your
textbook
lunch
gave us.
and ideas. Everyone is welcome. That's A12
It doesn't
meeting,
matter
planning
that it's
meeting today
different.
in room 2005.
What matters is what cancels.
Track and field. All throwers are to attend a practice today at lunch.
X-Z'll cancel. Y2Z'll cancel.
Please place your bins in the hallway. We'll be collecting them period.
Your overall will be
and
an
remember to place
X,
your garbage in trash
2
like coffee
Z's,
cups.
2
Thank you
Y's,
to Wesleyan
going to
teams
X,
that
Y,
are
2,
trying
Z,
to make
2.
recycling work.
So
Mr. Ainsley's recycling
3
crew
people
has
are sitting at
recently
this
noticed a
table.
surge of plastic collection.
You could have
We have
3 different
the
mechanisms
past
that
2
will
cycles
work.
of
So
collection,
you're just making.
we have
You're just making up a product.
The end product
Awesome
has
work,
to be the
Wesleyan.
same as the
The-
original.
This end product has to be the product up here, that's it.
Oh, okay.
Okay?
This still